Okay, so we're going to start reviewing for test 3-3. That's going to be on March 8th, that Friday. Extra help was March 6th after school. So you have tonight and then you have tomorrow night to watch this video. So the first two questions talking about converting from radians into degrees. To go from radians to degrees, the most important one that you should know is that pi radians is 180 degrees. Now this helps us here because here all you have to do is replace the pi with 180. So this is 4 times 180 divided by 3, which gives me 240 degrees. And then number 2, 11 times 180 divided by 12, which is 165 degrees for number 2. Okay? 3 through 6, this was on your last review sheet actually. Number 3 through 6, it doesn't say exact value, but keep in mind with our trig stuff that you have those decimals that you should know, so you should look to do this in exact value. So for number 3, well, for all of them, you are going to be in radian mode because here you have 3 pi over 2, pi over 6. You're always going to be in radian mode unless you see the little degree symbol, okay? It especially tells you that it's radians because of the pi. So for number 3, you're just plugging in 3 pi over 2 for x. So this is 3 times the sine of 2 times 3 pi over 2, and then plus pi, and then minus 4. Now you're not going to type the whole thing into your calculator because that gets rid of the exact value. So instead you're going to type this piece in. Okay? You end up getting something, it looks really nasty, but you see an E in it. Whenever you have E, that's scientific notation. So this is actually going to be 3 times 0. Okay, again, whenever you see an E, that scientific notation is probably going to mean 0. So 3 times 0 minus 4, which is negative 4 for number 3. Number 4, same idea. You're going to do 5 minus 8 times the tangent of 4 times pi over 6. You're plugging in pi over 6 for x. Again, you should be in radian mode. I type this into my calculator, and I end up getting negative 1.732, which I know is negative square root of 3. So when I clean this up, my final answer is 5 plus 8 square root of 3. The negative times the negative becomes positive. Number 5. 5 and 6, those are reciprocal functions, secant and cosecant. So you can't type those directly in. However, you can figure out their reciprocals. So you're going to essentially do, this is 3 pi over 4 plus pi and then minus 4. So in your calculator, you want to get this piece. So in your calculator, instead, you're going to type in the cosine of all of that. When you type in the cosine, you get the square root of 2 over 2. But then I don't care about that. I don't want the square root of 2 over 2. I don't want cosine. I want secant, so I flip that. So this is going to be negative 2 divided by the square root of 2 when you flip it. Then you have minus 4. Now, really shouldn't leave this as your answer because you don't want this radical being in the bottom. So you multiply the top and the bottom by the square root of 2. And now you get negative 2 square root of 2 divided by 2 minus 4. The 2's cancel, and you really get negative 4 minus the square root of 2. It's the same thing as negative square root of 2 minus 4, but usually you're going to see the radical coming at the very end. And then last one for this, number 6. So again, you can't plug cosecant into your calculator. Instead, plug in the reciprocal, which is sine. So I'm going to do the sine of 4 times pi over 2, all divided by 3 in my calculator. You can use that alpha y equals button here. That's going to be super helpful. So you're going to type the sine of that in, and when you do, you end up getting the square, you get 0.8660, which is the square root of 3 over 2, but I don't want the square root of 3 over 2. I flip it, so it's 2 over the square root of 3. Again, rationalize. So this is 3 plus 2 square root of 3 divided by 3. Or if you wanted to keep it in one fraction, you can write this as 9 plus 2 square root of 3 all over 3. The 9 came from, if I wanted this to be over 3, I multiply the top by 3, so it turns into a 9. Number 7 through 9. These are those long questions that we were doing right before we took that February break. So number 7, so first let's figure out where we are. If the tangent of theta is less than 0, tangent of theta is less than 0 in quadrants 2 and in 4. Cosine of theta is negative whatever. Cosine of theta is negative in quadrants 3 and 2. So I'm in quadrant 2. So I draw my angle. I draw my angle in quadrant 2. And then I go straight down to the x-axis. Now cosine is adjacent over hypotenuse. So this is going to be my theta here. So adjacent to theta is 12, and the hypotenuse is 13. Now remember, this is your origin. So if you head back this way, you have negative 12. That's where this negative came from. And then I do Pythagorean theorem to figure out my other side. So I'm going to do x squared plus negative 12 squared equals 13 squared. I end up getting that x is equal to 5, and it is a positive 5 because I'm going up 5 units. So now I can figure out everything. So cosine are already given, so sine is opposite over hypotenuse, so sine is 5 over 13, which means that cosecant is going to be 13 over 5. The cosine we said is negative 12 over 13. So secant is negative 13 over 12. And then the tangent is opposite over adjacent, so 5 over negative 12. And then the cotangent is the reciprocal, so negative 12 over 5. Okay, same idea for number 8. Cosine is less than 0, and cotangent is positive 7 over 9. So the quadrant where cotangent is positive, but cosine is negative, that's going to be in quadrant 3. So I draw my angle in quadrant 3. I go straight to the x-axis. So this is theta here. So now cotangent, that's going to be adjacent over opposite. It's the reciprocal of tangent. So adjacent is right here, and opposite is 9. Now because this is your origin, and you head back this way, this is negative 7, and you head down, so this is negative 9. Then to find the hypotenuse, you need to do Pythagorean theorem. So you do negative 7 squared plus negative 9 squared equals x squared. You end up getting x is equal to the square root of 130. Your hypotenuse is always positive, so you don't have to worry about that. This is the square root of 130. So now when you do sine of theta is equal to opposite over hypotenuse, so negative 9 over the square root of 130. But I have to rationalize that. So I multiply top and bottom by the square root of 130. This is my final answer. Negative 9 square root 130 over 130. Which means that the cosecant of theta, I don't want to flip my final answer because then I put the radical back in the bottom. So I flip my original. I get negative square root of 130 over 9. Okay. Cosine is adjacent over hypotenuse. So cosine is going to be negative 7 over the square root of 130. Rationalize, though, that becomes negative 7 square root of 130 divided by 130. And the secant, then, I flip my original answer, and I get negative square root of 130 divided by 7. Or I could also do hypotenuse divided by adjacent and get it that way. So now tangent. I know cotangent, I have two options. I could look and I could do opposite over adjacent, Or I know that cotangent is 7 over 9, which means that the tangent is going to be 9 over 7. Okay? And then the last one, number 9. Here I'm given a point. So I personally think that my job is easier when I'm given a point because I can easily see what quadrant I'm in. So this is going to be quadrant number 4. Think of where 6, -4 is. You're in quadrant 4. So you go over 6, down -4, because this point here is the 6, -4. Do Pythagorean theorem. You end up getting that C is equal to the square root of 52. The square root of 52, though, that is 4 times 13. So C is really 2 square root of 13. You should clean that up. 2 square root of 13. So now I have to find all of them. Sine of theta is opposite, this is theta, opposite over hypotenuse. So that's really -2 divided by the square root of 13. But then when I clean that up, that's going to be -2 square root of 13 over 13. I don't want a radical in the bottom. So then it's reciprocal cosecant of theta. I'm going to flip this one here because it's easiest for me to flip that, is negative square root of 13 divided by 2. Then cosine of theta is adjacent over hypotenuse. Same idea, that is 3 divided by the square root of 13. Rationalize it is 3 square root of 13 over 13. So then secant of theta. Again, I'm going to flip the one in the middle here. I could flip any of these 3 and still get the same answer, but this just has the least amount of work. Square root of 13 divided by 3. Tangent of theta. And now we have no more radicals, so we're fine. So tangent is opposite over adjacent, so -4 over 6, which is really -2 over 3. So then cotangent of theta, -3 over 2. Just flip it around. 10 through 12, you are just plugging in that value for theta and making sure that the identity still holds true for that. So here I would do the sine of 5 pi over 6. I get that number and then I square it. So plus the cosine 5 pi over 6. Get that number, square it. When I add the 2, I should get 1. So in my calculator, again, I'm in radian mode. Sine of 5 pi over 6 is 1/2 squared, plus cosine of 5 pi over 6 is negative square root of 3 over 2 squared equals 1. 1/2 squared is 1/4, right? 1 squared is 1 divided by 2 squared is 4, plus negative square root of 3 squared is positive 3 divided by 2 squared is 4. 1 plus 3 is 4 over 4, which is 1 equals 1, so it works. Okay, the second one that's there is deals with a lot of reciprocal functions. So same idea. So take a second now, pause the video if you have to. You're going to plug everything in and then square it after. Okay, so now remember, in your calculator you can't type in the cotangent. You have to type in tangent. So the tangent of 3 pi over 4 is -1. When I flip -1, I still end up with -1 squared equals. When I type in, when I want to do the cosecant, I have to plug in the sine and then flip that. So the sine of 3 pi over 4 is the square root of 2 over 2, but I have to flip that, so it's 2 divided by the square root of 2 now, and then -1. -1 squared is 1 equals 2 squared is 4 divided by the square root of 2 squared is 2, and then -1. 1 equals 4 over 2 is 2 minus 1. 2 minus 1 is 1. So 1 equals 1. That's it. Done. And then same idea for number 12. So I type in tangent of 4 pi over 3. That I can do right in my calculator, right? Because that's not a reciprocal function. And I get the square root of 3 squared equals. Secant I can't plug in, so I have to plug in the cosine. The cosine of 4 pi over 3, I end up with 1 over 2, or half. When I do the reciprocal of 1/2, I get 2 over 1, which is just 2. squared minus 1. Square root of 3 squared is 3 equals 2 squared is 4 minus 1. 3 equals 3. That one also works. So now we're going to move on to graphing. We are graphing all of these on the interval from 0 to 2 pi. So for number 13 you actually have to be very careful because here you have the plus 2 is in front of the sign. So be careful when you're figuring out the midline. So for number 13, the amplitude is 1. It's the number in front of the trig function. The midline is y equals 2. That means that my range goes from, if I have 2 and I go down 1, now I'm at 1, up until 3. The period is 2 pi divided by the b value, which is 2 pi divided by 3. So now when I go to graph this, we'll say that this is 1, 2, 3. I have to draw 4 slashes, and that is the period, 2 pi over 3. I go over another 1, 2, 3, 4. That is now 4 pi over 3. Another 4 slashes is 6 pi over 3, which is 2 pi. So now when I'm going to graph it, this is a positive sine graph. So a positive sine starts on the midline, and then I go up, midline, down, midline, up, until I finish out this interval. Okay? Again, this is a very rough sketch because I'm doing this on the iPad, but yours should be nice and curvy. And you shouldn't miss any points like I just did. But it looks like that. You're not going anywhere above 3, and you're not going anywhere below 1. Number 14. Same information. I need the amplitude, the midline, the range, and then the period. So the amplitude is going to be 3. The midline is y equals 5. The period is 2 pi over 2, which is pi. So now your range, you're at y equals 5. When you go down 3, you go down to 2. When you're at y equals 5, you go up 3. That's up to 8. So when I'm graphing this, again, I'm just doing sketches. You have graph paper on the back of your review sheet, so your graph should look a lot cleaner than mine. I'm just going to make this 2, make this 5, and make this 8 to show you what this should look like. So now I go over 1, 2, 3, 4, the period, which is pi. 1, 2, 3, 4, another period, 2 pi. So when I graph this, this is a negative cosine. So my y-intercept is on the 2. Is on the 2 because it's a negative cosine. So it's down here. And then I come up, up, midline, down, up. And this should look like this. Again, I have a very rough sketch on my paper. 15, same idea. The amplitude is 2. The midline is y equals 4, which means that the range, I'm at 4. If I go down 2, I go down to 2. And if I'm at 4 and I go up 2, I go up to 6. And then the period is 2 pi over 1, which is just 2 pi. So this is a nice short graph. So for this one, I have, let's make this 2. This will be my 4, and this will be my 6. I have 1, 2, 3, 4, 1 period, which is 2 pi. Here I'm done. Once I hit 2 pi, I'm done, because that's the graphing interval that I have for all of these. So now, I'm going to graph a positive cosine. So I start up here, and then midline, down, midline, up. So this should look something like this, but again, that's very bad, much better than that. And then the last one here is 16. So again, the amplitude is going to be 4. The midline is y equals -1, which means that the range, if I'm at -1, I go down 4, I go down to -5. If I'm at -1 and I go up 4, and I go up 4, I go up to 3. And then the period is going to be 2 pi divided by 1/2. 2 divided by half actually gives me 4, so this is 4 pi. So here, this is actually an interesting graph because you're not going to see everything here. So you go down to -5. Midline is y equals -1, and you go up to 3. Now, every 4 slashes is going to represent 4 pi, but I'm not graphing to 4 pi. My interval from the directions told me to graph until 2 pi. So if 4 slashes is 4 pi, 2 slashes is 2 pi. This is a negative sine graph. So sine, you start at the midline, and then because this is negative, I go down. And then I come back up, and that's it. That's all that you see on this graph. You only see half of a cycle because here, the b value is 1/2, and you're graphing from 0 to 2 pi. Numbers 17 and 18. For numbers 17 and 18, I just need to find what the phase shift is. Remember, your phase shift, you can tell from your trig function, let's say it's sine. The number of cycles gets pulled out, and you're left with x plus or minus whatever the phase shift is, or theta plus or minus whatever the phase shift is. So for number 17, I have to pull, this is 3 theta plus pi over 3. I have to pull the 3 out. When I do that, so if I do in my calculator, this is really 1 over 3, or 1 over 3 pi. In your calculator, you can do 1 divided by 3. When you pull the 3 out, you're dividing. So 1 over 3 divided by 3 gives me 1 over 9. So this is pi over 9 when you pull it out. So this is a phase shift to the left, pi over 9. Number 18 is a little bit easier. Number 18, you have to pull out a 2. You're left with theta minus. When you take 2 from 4 pi over 3, you get 2 pi over 3. In your calculator, if you wanted to do this, you would do 4 over 3 divided by 2, and you would get 2 over 3. So this is a phase shift. You should write out phase shift to the right, 2 pi over 3. Numbers 19 and 20. Number 19, you are writing the equation of a trig function, gives you the range, the period, and it tells you what point it passes through. And that point also happens to be your y-intercept, right? 0 for x value, that's a y-intercept. So my amplitude, let's do midline first actually. My midline is going to be y equals, it's what number is in between -4 and 6. So you can take the average of the two, -4 plus 6 divided by 2 gives me 1. So my midline is y equals 1. And then if I'm at 1, how far do I have to go? This is going to help me find the amplitude. How far do I have to go to figure out how far I go to get to 6? So if I'm at the midline, I need to know for the amplitude, how far do I have to go to get to 6 and to -4? I have to go 5. So my amplitude is going to be 5. The b value now, the period is 2 pi over 5. Now this helps me because the b value, the 2 pi divided by the b value gives me the period. So here you might be able to easily see that b is going to be equal to 5, or you can cross multiply. But either way, b is equal to 5. And then because this passes through the point 0, 1, the 1, that is your midline. So this is going to be a sine function. I also have to see whether it's positive or negative. In this case, you actually don't have enough information to know whether it is positive or negative. It would have to say it's increasing or decreasing through a specific, through 0, 1, or there would have to be more information. So you could say y equals positive 5 sine of 5x plus 1, or you could have the same thing but have a negative in front of the 5, in front of this first 5 here. So this is plus or minus 5 sine 5x plus 1. Number 20 is the same idea. So number 20, the midline. So if I do -5 plus -1 divided by 2, That tells me that my midline, the number that's in between -5 and -1, is going to be -3. Then for my amplitude, if I'm at -3, I have to go down 2 to get to -5 and up 2 to get to -1. So that means that my amplitude is going to be 2. The period is pi over 6. So 2 pi over b is equal to pi over 6. So this tells me that b pi is equal to 12 pi. So b is equal to 12. The last thing I have to figure out, positive or negative, sine or cosine. And that helps me here with the 0, -5. Because I passed, my y-intercept is at 0, -5, right here, it's going to be a cosine function. Because it's not on the midline, it's on one of the two amplitudes. And then because it's below the midline, it's going to be a negative cosine. So this graph is y equals -2 cosine of 12x minus 3. Last two. This is the two graphs, and you have to figure out what the equation is of these graphs. So I think it's easiest, and I think one of my classes told me that it was easiest to figure out what the midline is. Here, your midline is y equals -3. So that's the midline. The amplitude. I know that you're going up 2 boxes, but be careful because here you can see that 2 boxes are representing one movement. So you have to be careful of your scale. So your amplitude is actually just 1. And then the b value is from 0 until 2 pi. How many complete cycles do you have? So in this case, I have 1 cycle from 0 to 2 pi, so b is 1. And then the last thing, positive, negative, sine, or cosine. My y-intercept is down here. This is a negative cosine, so it's y equals -1 cosine of 1x. So if you just want to put x here, or 1x, doesn't matter. And then -3. And then the last one, same idea. Again, I always think midline is easiest to find. Your midline here is y equals 3. Your amplitude, how much you're going up and down, same idea here. You have to look at the scale. So if you're at y equals 3 and you have to go up to 4 and down to 2, your amplitude is going to be 1. Here, the b value, from 0 until 2 pi, I have 1, 2 cycles. And then lastly, positive or negative, sine or cosine. Here my y-intercept is on the midline, so it's going to be sine. And then I go up after. So this is a positive sign. So this is y equals +1 sine of 2x plus 3. Okay? Let me know if you have any questions. Again, your test is on Friday, March 8th. Happy studying.